What's up everyone, it's Mr. Lang. In this video I'm going to teach you how to find the average rate of change for two different kinds of functions, linear and exponential. So listen, you need the notes sheet that I gave in class. If you don't have that or you missed class, then you can just print it off from our website. I've got the blank one there. Anyway, let's get started. So as I said, we're going to find the average rate of change of linear functions and exponential functions. But before we get started, I want to do a quick review of what the slope formula is. And this will take us back to our linear functions unit. So the slope formula is rise over run. You can think of it this way. It has a lot of different ways we remember it. So rise over run's one way. Another way is change in y over the change in x. That's what rise over run means. The change in y is the rise, the change in x is the run. But most of the time the usable formula is y2 minus y1 over x2 minus x1. And that's the one you learned last year, I believe. We've used it this year. Now I want to show you one more. It's identical to this, at least identical in meaning. Remember how f of x really means y? They're kind of interchangeable. So another way you could see this is f of x2 minus f of x1 over, same thing, x2 minus x1. Most of the time I use this one, y2 minus y1 over x2 minus x1, but this is really the same thing, so you might see that occasionally. So let's actually get to some problems here. First, linear functions. Linear functions have a constant rate of change. So when you find the slope between any 2 points, that's the average rate of change for the whole function, since it doesn't change. So that actually makes finding the average rate of change quite easy. So the first kind of problem we'll see is where you're given a graph, we got a line here, and we want to find the average rate of change. Well, all we got to do is find the slope. And from a graph, just pick 2 points and count the slope. It's really that easy. So you always start with the leftmost point. I got to go up 2 for this one, and to the right 1. So my slope is 2 over 1, which also means my average rate of change, and I'm going to abbreviate here, ROC for average rate of change, is also 2 or 2 over 1. So slope, average rate of change for linear functions, same thing. From a table, it doesn't matter which 2 points you pick. You can pick any. I'm going to pick 5, 1 and 10, negative 3. And I'm going to use the slope formula here because I can't, count. So I can count. I just can't count from a graph because I don't have a graph. Anyway, we got 5, 1 and 10, negative 3. I like to label these. This is my x1, this is my y1, this is my x2 and my y2, and I'm going to use that slope formula. It's going to be negative 3 minus 1 over 10 minus 5. So my slope, negative 3 minus 1 is negative 4. 10 minus 5 is 5. So my slope is negative 4/5. So that's also my average rate of change. Alright, it's that easy. With lines, it's that easy. Just find the slope. Something you've been doing for a couple of years now. Now let's get to the exponential functions. Exponential functions have a variable rate of change. We saw that in just a little bit of work we've done with exponential functions. So they are not constant. So you can only find the average rate of change for parts of the graph. So what that means is, you see our exponential function here. The average rate of change, if we were just to look at the slope, it would be very close to 0 here. It's not steep. It gets a little bit steeper here, a little bit steeper. That's pretty steep. That's very steep. That's very steep. And if it kept going, you would see it keeps getting steeper and steeper. So you can't just say, well, what's the average rate of change of the whole function? You have to say, well, what's the average rate of change between 2 points? So the first one here is from 1 to 3. So what we basically want to do is say, well, what's the average slope from 1 to 3? 3 is right here. Well, at 1, this is the point 1, 2. And this is the point 3, 8. Well, what's kind of nice is if we have a graph, we can just do it just like we did before. And we can pretend that this is kind of like a line connecting here, and we're finding the slope of that line. So I would go up from 2 to 8. That's a jump of 6. And then I'm going to go over 1, 2. So my slope here would be 6 over 2, which I can reduce to 3 over 1. Now if you check this out, the slope from 1 to 2 is up 2 over 1, so it's only 2. But then when I go up here, it's a little bit steeper, and then this is much steeper. But if you average all those together, my average rate of change is 3. So really, when you're finding the average rate of change of an exponential function, you're basically finding the slope of the line segment that connects those 2 points. For the next one, it looks like there's a little minus there. Just scribble that out. I didn't mean for that. The slope from 1 to 2, well, in this case, I'm going to go up 2 and over 1. So the slope is 2 over 1. So that's my average rate of change. All right. So your SIA question is to do exponential example number 2. What you're going to do is, for each one of these, take the 2 points, find the slope between those two, and you're going to get your average rate of change. We'll go over it in class, and if you have any questions, you can always come see me. Thanks for listening.